the atomic mass of the substance changed to grams. Identifying types of reactions. So you're going to have the 5 types of reactions that we've discussed: combustion, single replacement, double replacement, synthesis, and decomposition. You'll be asked to recognize which type of reaction something is. Units of acceleration. Well, we had some up here a minute ago. There's one right there. Meters per second squared. Balancing equations. Empirical formula. What does that indicate? Well, it's the relative number of atoms in a molecule.
The relative number of atoms in a molecule?
Yes, relative number of atoms in a molecule. That's what an empirical formula is. A lot of these we've already gone over, and that's why I'm not saying anything. Okay, if you were given an empirical formula and you're given a molecular weight, could you find the true formula? We just did something like that earlier tonight. So you find the molar mass of the empirical formula and divide it into the molecular weight of the true formula, and that gives you a multiplier. That multiplier times the empirical formula gives you the true formula. Naming compounds. Okay, now that was the multiple choice, okay. I hope you can all answer this one. Right now, we're moving at about 800 miles per hour due to the Earth's rotation. Why are we not aware of this motion? That's a short answer question. I think you can all get that. Contrast the vertical and horizontal components of the motion of a football.
What?
Of a thrown football. In other words, projectile motion. So how would you describe projectile motion? Horizontally, at constant speed. Vertically, constant acceleration. That's the shortest correct answer.
Say that one more time.
Horizontally, constant speed. Vertically, constant acceleration. Then you're given some problems where you're given the name of a compound and asked to write the formula. Then you've got some others where you're given the formula and asked to name the compound. Here's one on percent composition. You're given a formula and you're asked to give the percent composition, and this particular formula has carbon, hydrogen, and oxygen in it, but you could do it with any formula. Here's a vector problem, just very much like the one we worked up here a minute ago, where you add 2 vectors, and then a vector problem where you take one vector and split it up into its 2 components. Same thing we just did on the board. Find the empirical formula when you're given the percent composition. We've done several of those. A few Lewis structures, and these will be pretty easy ones. And that's what was on last year's test.